Let's look at replication in prokaryotes. This is the DNA helix that we'll be replicating. As you can see, it's pretty standard so far, but we're going to get a visit from Mr. Initiator Protein. Here he is, coming in, and he decides it's time to replicate and designates our origin of replication. After the origin is designated, Mr. Initiator Protein brings in a couple of his helicase friends. These helicases will attach at each end of the origin and begin breaking the hydrogen bonds between our strands, unwinding the double helix. As you can tell, helicase is a bit aggressive and can cause some unrest within the helix, namely torsional stress. But not to worry, we have our other friends, gyrase, here to help manage the torsional stress and prevent supercoiling. Now that our two strands are separating, we can begin replication. Here, we've zoomed into our DNA at one of the replication forks so that we can see our nucleotides. It's important to remember that replication can only occur in the 5' to 3' direction. With this in mind, we'll start by looking at our red strand, which is 5 to 3 from left to right. Now, because strands are complementary, the new strand that will bond to this one will have to be in the opposite direction, aka 3 to 5. So this means replication on the red strand will be directed towards the left or into the fork. Because we're leading into the fork, we call this our leading strand. So to build our new strand, we'll need a 3' OH to attach to. Well, we don't have one right now, so we'll use an RNA primer to give us that start. With our primase in place, we can build our nucleotides, like this, using DNA polymerase III to create phosphodiester bonds. Wow! Now let's shift our attention to the yellow strand. So since our top strand was going left into the fork, we can expect this one to be directed right, away from the fork. However, because we're building away from the fork, we're going to have to build in a more staggered fashion, like this, since we have to wait for parts of the fork to open up before building our strand. Because of this, we call this strand the lagging strand. So, just like the red strand, we'll use our primase as a starter, and this time build towards the right like this. Then we'll move closer to the fork and do the same thing. You'll notice when our strand is built in this way, we end up with our new strand in pieces, which we call Okazaki fragments. Clearly, we need to connect these. In order to connect our fragments, we'll first need to remove the RNA primer with the help of DNA polymerase I, which cleaves this out of our strand. Now we're left with this nick in our strand that needs to be filled. To fill our nick, we call our last helper ligase. Ligase connects our fragments and finally gives us 2 complete DNA helixes. Yay!